Welcome to the dissociation video. This is Jim Hart, your narrator. We're going to focus in on what happens when we dissolve ionic compounds in water. And we are going to just focus in on ionic compounds. Other types of compounds, molecular compounds, dissolve in water too, but we're going to focus in on ionic compounds. You already know a lot about ionic compounds, and you're going to use that knowledge here. Here is our first appearance of the Thinker Buddy. And what we're going to do here is just review the naming that you already know. So what you need to do is look at these formulas and write the names that correspond to those formulas. These are all ionic compounds. That's all we're talking about here. So we don't have to identify them, just have to name them. So I will give you a chance to pause the video now, and after you've completed it, restart the video and we'll move on. Welcome back. These are the names that you should have gotten. So sodium carbonate, magnesium chloride, iron 3 nitrate, and copper 2 sulfate from those formulas. Keep in mind that subscripts can either represent how many of each ion there are, that's the case for that 2 there, or they can be part of the formula. That 3 is part of the formula of carbonate. So keep that in mind as you go through and do these things. Remember the rule with parentheses. You only use parentheses in the formula for an ionic compound if you have more than one of a particular ion in the formula. And the only place that I see parentheses here are in the example of the iron 3 nitrate. That's because I have the nitrate ion and I've got 3 of them. So this 3 that I've circled is the number of nitrate ions. This 3 that I'm underlining, that's part of the formula of nitrate. So remember all that when you're looking at a formula of an ionic compound, you're expected to know what the ions are. That's the beginning of all this stuff in solution, and we use that throughout. It's very, very, very important. Now when we look at these, we've got the formula and the name. We can also write out the formulas for the actual ions. If they were separated, how would we write them if we just want to focus in on the ions themselves? And I've done the first example. I've shown that there are sodium ions and carbonate ions in sodium carbonate. Well, we know that because that's what the name is. It's the name of the ions in the compound. It is that obvious and straightforward. That's why the system is favored by chemists, because it's simple and obvious. So we've got sodium ions and carbonate ions, and how many of each? Well, we've got 2 sodium ions and 1 carbonate ion. That's what I want you to do here with the Thinker Buddy. I'm going to give you a chance to pause here in a second. Go through and list the ions and how many of each there are. List the cation first, followed by the anion, with how many there are. So go ahead and do that and restart the video when you're done. This is what you should have obtained. That there are in magnesium chloride, there is 1 magnesium ion and 2 chloride ions. In iron 3 nitrate, there's 1 iron 3 ion and 3 nitrate ions. And in copper 2 sulfate, there's just 1 ion of each. So just remember that sometimes it's hard to identify that the 2 is not part of a formula of an ion. It's how many chloride ions there are. But here, this 4 is part of the formula of the sulfate ion. So it's very important to review your naming when it comes to working in solution. So once you're comfortable with that, we can move forward and things become pretty simple for the dissociation process. We're just going to represent it with a chemical equation where we start out, we want to think about taking a solid ionic compound like sodium carbonate, and we put it in water. And a way to represent that is to draw an arrow and then write the formula for water above the arrow. And go ahead and then on the product side, write the ions and how many there are of each, separated by a plus sign. And we also want to include the phase label for something dissolved in water, which is the AQ symbol for aqueous. Once we've done that, we have represented how this compound goes into solution. It goes in as the ions. So the Thinker Buddy again, go ahead and do the rest of these. I'll give you a chance. Go ahead and pause the video. Start it up again when you're finished. These are the ions that are in each of these solutions once you dissolve these ionic compounds in water. It's basically what we did in the previous slide, except we are separating them by a plus sign. We're not writing the one in front if there's only one of the ion for every formula. Now, we've shown in the previous slide, we showed the ions separated in solution. We can also write it in a more condensed form by just taking the whole formula together and putting an AQ after it. So this is exactly the same as what we've written before. It's just a little more condensed way of writing it. But keep in mind that when it's in the water, that we put the AQ after the symbol for the compound. That means that it dissolved in water. And because it dissolved in water, it went into solution as the separated ions. So that AQ after the formula for the ionic compound means that I've got 2 of those sodium ions for every one of those formulas floating in the water, along with 1 carbonate ion floating in the water. And that's the same is true for any ionic compound that dissolves. Notice that sodium carbonate, for every formula you get 3 different particles, 2 sodium ions, 1 carbonate ions. Same is true for magnesium chloride. You get 3 particles, 1 of the cations and 2 of the anions. For iron 3 nitrate, you get 4 particles. For copper 2 sulfate, you just get 1 of each, 1 cation and 1 anion, so a total of 2 particles. This stuff becomes really important when we think about colligative properties later. When you have ionic compounds, the only way they can go into solution is by separating into their ions. So when we write that symbol of the sodium carbonate with an AQ after it, it doesn't mean we have those units floating around together. Remember, this is an ionic compound. It's not a molecule. It goes into solution as the separated ions. So even though it's written kind of like it's together, it's not really together. Keep that in mind. That's kind of an important idea. So I think we're ready to go on. The solubility rules, we'll talk about ionic compounds that either do dissolve in water and make the ions, or they just sit there and don't do anything. They stay the solid. So go ahead and move on once you've mastered this video.